All right, so we're going to do our set of notes for 6.4. So we just talked about finding and did some homework on finding the lowest common multiple, which is the same thing as your least common denominator, which you needed when you were adding or subtracting fractions. Now we're going to talk about the greatest common factor. So the greatest common factor means that you want the biggest number that divides into both, in this case, 15 and 30. The least common multiple means you want 15 and 30 to divide into that larger number. Greatest common factor means you want the largest number that divides into both 15 and 30. So if you think about this, what are the numbers that divide into 15 evenly? Well, 1 divides into there evenly, 3 divides into there evenly, 5 divides into there evenly, and 15 divides into there evenly. Those are your factors of 15, all the numbers that go into there evenly. If you're talking about the factors of 30, well, it would be 1 goes into there evenly, 2 does, 3 does. These are all the numbers that divide into 30 evenly. 5 does. 6 does, because 5 times 6. 10 does, because 3 times 10. 15 does, and 30 does. So these are all of the factors of 30. So we want the biggest one that they have in common. Well, you can see that the biggest one that they have in common is 5. 5 goes into 15 evenly, and 5 goes into 30 evenly. So our GCF, which is our greatest common factor, is 5. If I look at 9, 12, and 36, what's the biggest thing that divides into all of these? 9, 12, and 36. Well, the biggest thing that divides into all of them is going to be 3. The only thing that divides into 9 is 1, 3, and 9. So the biggest thing that divides into all of them, or the greatest common factor, would be a 3. So don't get it mixed up with the least common multiple. They're very different. So another way to find it, a procedure you can do to find it, would be write each term of the expression as a product of prime factors in exponent form. So that's making your factor tree. Identify the common prime factors and or variables that have the smallest power. Remember, for the LCM, we looked for the largest power. And then, of course, you multiply everything out in the end. So if we wanted to use that method for 28 and 21, now hopefully a lot of these you're going to be able to do in your head. But if we wanted to use that method for 28 and 21, if we went ahead and did our factor tree for 28, we've done factor tree, so that's 4 times 7. Then, of course, 4 breaks down into 2 and 2. So 28 is 2 squared times 7. And then you have a cubed. If you make your factor tree for 21, that's simply 3 times 7. So that would be 3 times 7, and then a to the 4th b. So now for your greatest common factor, you take what they have in common. Well, the only thing that they have in common is a 7. So 7 is their greatest common factor number-wise. Letter-wise, they have an A in common. They do not have a B in common. They don't share that. And then you take the smallest exponent that comes off the A. So that you can see that that is 7a cubed. And that is your GCF for these two expressions. So again, you take what they have in common, including the variables, and you take the lowest exponent. If I look at here, well, there are no numbers, so the GCF is 1, so you don't have to worry about that. What do these two expressions have in common? Well, they have a B in common, and they have a C in common. They both have them. And then you take the lowest exponent on each one. The lowest exponent on a B would be a 3, and the lowest exponent on the C would be a 1. So your greatest common factor would simply be B cubed C. Here, I'm going to write another one here. It's not in your notes, but let's just practice one more time for the greatest common factor. So let's say I had 12x squared y cubed. And let's also say that I had 20xy to the 5th. So write that down. All right, so now let's think of this 12 and 20. What's the largest number that divides into both 12 and 20? If you can't think of what that is, then you can go ahead and do your prime factoring. So if I do 12 up here, that's 4 times 3, but the 4 breaks down into, 2 and 2. And then if I do 20, 20 is 4 times 5, but again, the 4 breaks down into 2 and 2. So if I look at their prime factored forms, I'm looking at 2 squared times 3, and then x squared y cubed. That's your 12, x squared y cubed. And then for this one, I'm looking at 2 squared times 5 times x, y to the 5th. So my GCF, what do they have in common? They have the 2 in common, and they actually have 2 squared in common, so it's 2 squared. They have an x in common, and they have a y in common. What's the smallest exponent on an x? Well, that's to the first power. And the smallest exponent on the y is to the third power. So my GCF is 4, because that's what 2 squared is, x, y cubed. So now that we know how to find the GCF, what we're going to do is we're going to use that to factor. Now you're going to learn all different types of factoring when you get to Math 53. For this course, the only type of factoring you're going to use is what I'm about to teach you. Whenever you factor something, what you're doing is you're unmultiplying it. When you factor the way we are going to factor, what we're really doing is undistributing. So let me show you an example here. So the first thing you do is you find the greatest common factor in each one of the terms. Well, the biggest number that divides into both 16 and 20 is 4. Now, do they have a y in common? No, they don't, because only one of them has a y. So now what you're going to do is you're going to undistribute the 4. And in parentheses, you're going to write what's left. And you write what's left, or you get what's left by dividing. Look, 16 divided by 4 is 4, and there's still a y left. And 20 divided by 4 is 5. This is the factored form of 16y plus 20. Now look, you can always check your answer by redistributing and see if you get what the original problem was. If I distribute this, I would get 16y plus 4 times 5 is 20. So again, what we're really doing is we're undistributing some expression. We're undistributing the greatest common factor. If we look at B, what is the biggest thing that divides into 9, 6, and 12? Well, hopefully you can figure out that that's going to be 3. That's going to come out of all of them. Now, do they have an A in common? No. Do they have a B in common? No. You can only take out what all of them have in common. So now when I write what's left, 9 divides by 3, there's going to be a 3a left in that first term, plus 6 divided by 3, there's going to be a 2b left, minus, and then 12 divided by 3 is 4. And there is the factored form. If I distribute back through, I'm going to end up with this exact problem. All right, let's do C, and then I think you should pause the video and you should try D on your own. But let's do C together. Okay, so 27 and 36. What's the biggest thing that divides into both of them evenly? It is 9. 9 divides into both of them. So that's the number. Now look, they have some variables in common. They have an a in common, so we're going to factor out an a. What is the smallest exponent? It's a 1, so that's all we can take out. They also have a b in common, and the smallest exponent on a b is a b squared. So that is our greatest common factor that we're going to factor out. Okay. Now we have to write what's left when we factor it out. 27 divided by 9 is 3. Now how many a's are left? Remember, we factored out that a, so there's no a's left. We factored out 2 of the 3 here, so there's 1 b left. Minus 36 divided by 9 is 4. If we look at the a's, I took 1 out, which means that there's 1 left. And if I look at the b's, look, there's no b's left. You can also think, when you do the variables, you can think of it as dividing. A divided by a, those cancel out. B cubed divided by b squared. Remember, you subtract your exponents, so there's 1 left. When I do this term, a squared divided by a, there's 1 left. And b squared divided by b squared, there's 1. There's none left. So that is your factored form. And again, you can check it by distributing back through. Now pause the video and you guys try to do D. All right, hopefully you've tried it. If I look at 12, 4, and 6, the biggest thing that divides into each one of those is 2. So I'm going to take a 2 out. They all have an x in common, so I look for the lowest exponent. That would be a squared. They all have a y in common, and again, I look at the lowest exponent, and that is also a squared. So now let's write what's left, and we're going to do that by dividing. 12 divided by 2 is 6. X to the 5th divided by x squared, that means that there's 3 left. And y cubed divided by y squared, there's a y left. Minus 4 divided by 2 is 2. X cubed divided by x squared, there's an x left. And y cubed divided by, oops, we're over here. Y to the 4th divided by y squared is y squared. And then plus the last term, 6 divided by 2 is 3. X squared divided by x squared, those are all gone. And y squared divided by y squared, those are all gone. And there is your factored form. And again, you can distribute through and make sure you get the original. Last one, sometimes it's advantageous to factor out a negative number. And in this case, since they're both negative, we're going to do that. So the biggest thing that divides into 3 and 6 is 3, but we're going to take out a negative 3. Notice they have an r in common as well. The lowest exponent is an r to the 1st, and they also have a t to the 1st in common. So we are going to take out a negative 3rt. Now look what happens when I write what's left and I get it by dividing. What's negative 3 divided by negative 3? That's positive 1. R squared divided by r is r, and t divided by t, those are done. Now negative 6 divided by negative 3 is plus 2. R divided by r, those cancel out. T squared divided by t, there's going to be a t left. So it would be negative 3rt 2t times 1r, which is r, plus 2t. And again, you could distribute that through, and you should get what you have left. And there are those notes.